Hi everyone. In section 2.6, we're going to focus on exponents, algebraic expressions, and a very important topic on the order of operations. Okay. The first thing we want to do is find a more convenient way to write a repeated multiplication. For example, if we take a collection of 5 threes and we multiply them together, that would be 3 times 3 times 3 times 3 times 3. We know the answer is going to give us 243. A faster way to write a repeated multiplication like this is what's called exponential notation. In exponential notation, there's two key components. The bottom number, which is called the base, tells us which number we're going to be multiplying, and the superscript, which is written in the upper right hand corner, tells us how many of those we are going to have, and that's referred to as the exponent. So if we write something like 3 to the 5th power, the base is 3, so that's the number we're going to be using in our multiplication, and the exponent tells us how many of them we have. So 3 to the 5th represents 3 times 3 times 3 times 3 times 3. It's very important that we pay attention to what is the base and what is the exponent. For example, if I were to say something like 5 to the 3rd power, this is much different. This time the base is the number 5, so that's the number you would be multiplying, and the exponent is 3. So 5 to the 3rd, what that would represent would be 1, 2, 3 fives all multiplied together, and of course that's going to be 125. Okay. So if it helps, think of the base as the bottom number, and then one that's in the top is going to be your exponent. If an expression doesn't have a stated exponent, it's always understood to be a 1. So if you have the number 9 or just 1 9 by itself, that's 9 to the 1st. Or if it's a variable, if we have like x is understood to be to the 1st power. A lot of times we'll give a couple special names to the powers of 2 and 3. If you have 6 to the 2nd power, this is also referred to as 6 squared. If we have something that's being raised to the 3rd power, we'll often say that base is being cubed. So 6 to the 3rd could also be read as 6 cubed. And then for exponents higher than 3, we generically say it's raised to the nth power. So for example, if I had 6 to the 4, we would read this as 6 to the 4th power. If we have 6 to the 5, that would be read as 6 to the 5th power. The first skill we want to develop is to be able to write things in exponential form. So we know we need a base that's going to be raised to the exponent. The base is the number that we're using. So if I look at this multiplication here, we're using the number 2. How many 2's do we have? Well, we have 3 of them. So this would be 2 to the 3rd power. If we look at expression B, here it's the number 4 that's being used, and we have 5 of them. So that would be 4 to the 5th. And then over here in part C, we just have one factor of 7, which is all by itself. So that's 7 to the 1st power. In example 2, we're going to work backwards. So now we have it in exponential notation, and they only ask us to write it as a repeated multiplication. They don't actually ask us to go all the way and find the value here. So if I look at something like 7 to the 2nd, or we could call it 7 squared. The base is the number we're multiplying, and the 2 tells us that we're going to have 2 of them. So we're going to have 2 7s. So 7 squared represents 7 times 7. Over here, the base is 6, and the exponent is 3. So 6 to the 3rd, or 6 cubed, would represent 6 times 6 times 6. The next thing we're going to do is we're going to evaluate, which means to find the value of the given expression. So if we have something that is in exponential notation, we can rewrite it as a multiplication and then multiply it all the way out. For example, if we have something like 3 to the 3rd power, this represents 3 times 3 times 3. Multiplying them 2 at a time, 3 times 3 is 9, and then 9 times 3 would be 27. Over here we have 1 raised to the 9th power. This is going to represent the multiplication of 9 ones. And we know that 1 times itself is going to be 1. 2 to the 4th, the base is 2. And we have an exponent of 4, so it's 4 2's all multiplied together. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 would give us a value of 16. So 2 to the 4th equals 16. One of the things we're going to have to be very careful with and pay close attention to is whenever we have exponents along with sign factors or even opposites. For example, if I look at example A here, it's always important whenever you have an exponent to be very explicit as to what is the base. Here, the base for this problem is going to be -3 because it's inside of a parenthesis, and so that's the thing that's being raised to the 4th power. So -3 parentheses to the 4th represents the multiplication of -3 with itself 4 times. Okay. Once we're able to write out and we understand what this means, we just have to do this multiplication. A shortcut for this, remember we talked about what happens if you have a bunch of negatives multiplied together. Here we have an even number of negatives. There's 4 negative signs. So the final answer is going to be positive. 3 times 3 times 3 times 3. Well, that should give us 81. So the final answer for this one is going to be a positive 81. Something that looks awfully similar here, but is slightly different, is this problem in part B. We have kind of the same 3 components. There's a negative sign, a 3, and a 4. But notice in this example, the negative sign is not in the parenthesis with the 3. So what this means is we're going to take the opposite of 3 to the 4th. So on this problem, the base is actually the number +3, and it's being raised to the 4th power. So we're going to take 3 times itself 4 times. 3 times 3 times 3 times 3 is 81. And at the very end, again, that negative sign that's out in front tells us to take the opposite of 81, which gives us a final answer of -81. Again, these two problems look very similar, but the parentheses play a huge role here. In this problem, the base was -3, which resulted in a final answer of +81. But over here, the base was just the +3. So we did 3 to the 4th to get 81, and that sign out in front says take the opposite to get a final answer of -81. We now come to the very important concept of order of operations. So for us, this will probably be one of the most important sections we learn all semester in terms of how to compute various expressions. Some of you might know this by the acronym PEMDAS, or the saying, "Please excuse my dear Aunt Sally." We have to be a little bit careful with that in terms of the way this is going to run, though. So whenever you have a calculation, the first thing we want to do is the parentheses, or generically any kind of grouping symbol. So the P in PEMDAS stands for parentheses, but it could be things like brackets. You might have literal parentheses, or if you have like absolute value bars, which we'll see in a minute, or if you have like a square root with something inside of it, anything that's grouping something should be done first. You would do what's on the inside of that. Once we've done any operations with grouping symbols, the next step we move to is going to be our exponents. So exponents would be the second thing we do. The third step after handling exponents is multiplication and division. And this is where PEMDAS can be a little bit misleading, because multiplication and division should be done from left to right. Okay? So whenever you get to multiplication and divisions left, we do them going from left to right. So even though the M looks like it comes before the D in PEMDAS, those two carry the same importance. So whichever one comes first is the one you would do first. Okay. For example, if I have 6 divided by 3 times 2, all we have is divisions and multiplications, so these need to be done from left to right. 6 divided by 3 is 2, and then 2 times 2 would be 4. A lot of people will make the mistake and take PEMDAS too literally, and they say, oh, PEMDAS, M before D, And so they mistakenly think that you need to multiply these two first. That is not the case. Division and multiplication carry the same level of importance, and they need to be done going from left to right. When we read this problem from left to right, the division comes first, so we do the division. If I change a problem around, let's suppose I have 6 times 2 divided by 3. It's the same idea. As I go from left to right, this multiplication comes first. So in this problem, I would do the multiplication. 6 times 2 is 12, divided by 3, and 12 divided by 3 would give us an answer of 4. Okay. Similarly, when it comes to addition and subtraction, the last step, those both carry the same level of importance as well. So additions and subtractions have to be done going from left to right. Okay. Let's take a look at example 5. We want to simplify, or really the directions probably should say evaluate these. So again, think of like your PEMDAS, your order of operations. If we have any grouping symbols, we're going to do those first. Here we do have a parenthesis. So we're going to do 3 plus 7, which would give us 10. Now that the parenthesis is done, there's no exponents. And the last operation is a multiplication. 10 times 5 gives us 50. In part B, we do have kind of a grouping type symbol, namely that we have absolute value bars. Before we can take the absolute value here, we have to know what number is going to go on the inside. So I do the inside part first. 6 minus 16 is going to give us negative 10. We know how to do the absolute value of negative 10. The absolute value of negative 10 is going to be positive 10. Now, what is the last operation here? Well, this is something that we have to kind of pay attention to. When we look at the beginning of the problem, that number 8 was written directly up against and beside the absolute value bars. The operation isn't explicitly stated, but there's an implied multiplication here. Kind of like in a little bit when we see something like 8 times x. 8 times x really means take the number 8, which is the coefficient, and multiply it by the variable x. Same thing here. This really means take 8 and multiply it to the absolute value of negative 10. We know the absolute value of negative 10 is 10, and so we do 8 times 10 to get our final answer of 80. Let's take a look at example 6. In part A, we have a parenthesis, so we have to do parenthesis first. 2 times 5 will give us 10. Now that the grouping symbol is done, we can do the exponent. 10 squared, we know that that means 10 times 10, which should give us 100. For part B, we have 2 times 5 squared. Again, order of operations, there's no parentheses. We do have an exponent, so we would have to do that first. 5 squared, remember that means 5 times 5, which is 25. Now that we've done the exponent, we can do the multiplication. 2 times 25 should give us 50. So final answer on this one is going to be 50. Let's take a look at example 7. Again, we're asked to simplify or evaluate this expression. This is a good example that as the problems get longer, the sooner you can develop good habits, the better off you're going to be. So typically, if I'm doing a long order of operations type question, it's important to kind of take your time, go step by step, and just continually write everything as you're going down. So again, thinking of our order of operations here, our good old PEMDAS, please excuse my dear Aunt Sally. We need to start with grouping symbols first, then exponents, multiplications and divisions done from left to right, and addition subtractions done from left to right. Okay. The first thing I kind of noticed is that we do have a grouping symbol here, which is these brackets. Okay. So according to order of operations, I would have to do what's inside of those brackets first. When we look inside of those brackets, the order of operations kind of starts all over again, meaning if we have any other nested brackets or grouping symbols, we should do those first, and we do. We have this parenthesis right here, which tells us to do 8 minus 10. So let's start here with this innermost grouping symbol. We have 18 divided by 6 plus 4 bracket 5 plus 8 minus 10. We know that that's going to be negative 2 to the third power. So I did my first step, and I just recopied everything else going straight down. We're still in this kind of bracket grouping symbol. We did the parentheses that was in there. The next thing we have is this exponent. So we're going to do the exponent next. Negative 2 to the third, maybe I'll do this off to the side. This means negative 2 times negative 2 times negative 2, which should be negative 8. So we're going to do that part, copying everything else down. Like this. So the exponent is done. We're still working within this grouping, this bracket. We did the sub-bracket or subgrouping symbol. We did the exponent. We have an addition, and we have, again, this implied multiplication. We know multiplication comes before addition, so we need to do 2 times negative 8. Two times negative 8 should give us negative 16. And the last operation that's in here is now this addition. We have 18 divided by 6 plus 4 times 5 plus negative 16 is going to be negative 11. And again, I say times because this 4, which is directly beside this bracket, whenever something's written directly beside something, it's implied multiplication. We're finally done with that first grouping symbol, so we just have the number negative 11 on the inside. There's no remaining exponents within the problem. So now we're to the multiplication and division step. And again, we're going to do this from left to right. When I scan this problem going from left to right, the first operation I see show up is this division. So I'm going to do that next. 18 divided by 6 should be 3. Plus 4 bracket negative 11. Now that I've done the division, we have this multiplication to take care of. 4 times negative 11 is negative 44. And there's one operation left. We have addition. 3 plus negative 44 should give us negative 41. So final answer here is negative 41. Let's take a look at part B. In part B, we have a fraction, so it's really kind of like a division here. We want to take the numerator times the denominator, but before doing that, we need to figure out what is the number in the numerator and what is the number in the denominator. So we can kind of work these two out independently. In the numerator, our very first step would be the grouping symbol. 3 minus 12 is going to be negative 9. In the denominator, our first operation would be that of exponents. 2 to the fourth means 2 times 2 times 2 times 2. That's going to be 16. In the numerator, we now just have a bunch of multiplications and additions. Multiplication comes first, going from left to right. 2 times negative 9 is negative 18. In the denominator, 16 plus 1 is 17. I'm going to do the next multiplication up top. 6 times 4 is 24. And now we can go ahead and add. Negative 18 plus 24 would give us positive 6 over 17. 17 will not evenly divide 6, nor as a fraction do 6 and 17 have any common factors. So we can leave our final answer like this. It's just going to be the proper fraction 6/17. Let's take a look at number 8. We have the square root of 64 plus 36 minus 2 to the third. Again, if we're thinking of PEMDAS, our order of operations here, multiplication, division from left to right, addition, subtraction from left to right, we do have a grouping symbol. Okay, it's not a parenthesis or a bracket, but the square root kind of plays like the role of a grouping symbol. In order to take the square root, we need to know what number is on the inside of that square root. So let's do the inside part first. 64 plus 36 is going to give us 100. And then the square root of 100 would just be the number 10. Okay. So your square roots and also your absolute values, those also get done at the parenthesis or grouping symbol level of the order of operations. Now that we know what number was there, but it's number 10, we can look for the next step, which would be exponents. We do have the exponent 2 to the third. That's 2 times 2 times 2, which is 8. And then lastly, 10 minus 8 would give us a final answer of positive 2. The next step we're going to talk about is that of algebraic expressions. Typically, there's two roles that algebraic expressions play. They can either be used to represent an unknown quantity in an equation, or they can be used to represent a quantity that varies as a certain variable changes. One of the most important skill sets we want to develop is the ability to evaluate the variables for a certain particular real number value. For example, if we're asked to evaluate the expression x squared minus 7x for x equals to 2, what this means is everywhere we see an x, we're going to replace it with the number 2. After replacing the variable with its number, we're then going to perform the order of operations to evaluate and figure out the value of the expression. One of the best things and the best piece of advice I will probably give you all semester is whenever you're trying to rewrite an algebraic expression, what I like to do is what I like to call write out the statement form of that expression, where I simply take and replace the variable with a parenthesis. So x squared minus 7x, the statement form would be input squared minus 7 times input. And if I do that, then by putting those parentheses there, I now have a location to plug my value into. So everywhere I saw an x from before, I'm going to plug in and put the number 2. And if you get into this habit, and if you start to do the evaluation like this substitution step will help you a lot, especially if you have things that have like a lot of negative signs or negative values for the variable. Once it's plugged in, we just now need to find the value. We have our parentheses, but they're just kind of grouping our numbers, so just use as placeholders. We go to exponents next. 2 squared is 4, minus 7 times 2. Again, 7 times 2 is side by side. It's implicit multiplication. So we do the multiplication next. 7 times 2 is 14. And then lastly, we subtract. 4 minus 14 is going to give us negative 10. Let's take a look at another one. Here in example 10, we want to evaluate this expression. So we have 3 variables, and we have 3 values. X is going to be 12, Y is going to be 9, and Z is going to be 4. So this is kind of what our expression looks like. It's the X value minus the Y value minus the Z value, whole thing to the second power. Everywhere I see an X, I'm going to put a 12. Everywhere we see a Y, I'm going to put 9. And everywhere we see a Z, I'm going to put 4. Okay. So key step, we get everything substituted into the correct spot. We're now going to use order of operations to evaluate this. We have a parenthesis, so we have to do what's in the grouping symbol first. Within that grouping symbol, we only have subtractions, so they get done from left to right. 12 minus 9 would give us positive 3. That positive 3 minus 4 would give us negative 1. So the number negative 1 is what's in the grouping symbol, and that's the number we need to raise to the second power. Negative 1 to the second power is negative 1 times negative 1, which is going to give us a final answer of positive 1.